Greetings, chemistry students. Mr. Rosentos here. And we're in chapter 1, and I'm talking about the scientific method. The scientific method is important because people still have some errors in their thinking regarding science. People still believe that if you touch a baby bird, the mother will never ever take care of it. It'll abandon the nest. People believe that my favorite is that your blood, it's blue until it reaches the surface, and it magically turns red. These people have loads of these. Or another good one is that there's a magic pill that you could take and lose loads and loads of weight. People think unscientifically. There are limitations to science, but people think that they understand the scientific method, but these terms are complicated, and I want to unpack some of the complicated terms now. The scientific method is an unbiased way to answer questions about how nature works. Speaking of unpacking, unbiased, you should know that what the hallmarks of a good scientific experiment is that it's unbiased, meaning you are not bringing preconceived notions into the experiment. You don't start with a conclusion and then set up your experiment to prove that conclusion. That would be a biased experiment. You must not bring preconceived ideas to your experiment. If somebody knows what their outcome should be and then they design the experiment to prove it, that is not science. But we first start with a problem, and the problem and the observation are first two steps in this scientific in this process. And an observation are the first facts that you have regarding a problem. The key word there is facts. You must be able to distinguish if an observation is being made that has facts or it lacks facts, such as baby birds are not taking care of their young because of spirits, or baby birds are not taking care of the young because they resent the fact that they make them work. These are not based on facts or observations. That's based on maybe some preconceived notions that you might have about your resenting, your parents, etc. You leave those things. You just pick up the facts that you see. A hypothesis is an educated guess. We've probably learned this. There's two terms I want to add to this, and that is that it's a good hunch, it's a good guess that is testable and it's falsifiable. So I want to keep adding on some important features to things that you probably already know. An example of a hypothesis is that our universe is surrounded by another universe, but we haven't made contact yet. All right, so is this testable? Absolutely not. If we haven't made contact to it, it's not testable. Somebody cannot say that this is a scientific hypothesis. This you would call speculation. It's not of science because you cannot test it yet. And if you can't test it, you can't falsify it. And I'll talk more about the importance of falsifiability in a minute. Science is interested in proving something false more than whether it's true. All right, so people say, well, is it true that lightning strikes only once? Well, really, we're more interested in proving that that's false, because there are places where lightning strikes more than once. Now, we're not going to. Science tries to stay away from what is true, but what we are more interested in doing is saying that hypothesis is false, that it only strikes in one spot once. Lightning doesn't do that. It does strike in one spot more than once, and that is proven. All right. So, but we try and stay away from that which. The word truth. Truth is something that you develop as a result of your experiences in life, but it's not really the substance of science. Okay, so speculation is not a hypothesis, and a speculation, as I said before, is really an observation that lacks that lacks good factual recordings. All right, so here's another one. Our observation is that more people purchase beige guitars than red or green. That's an observation. It's just filled with facts. You can collect these numbers. Hypothesis: if customers are given a choice between colors, then they will purchase beige guitars. Nice hypothesis because it has a nice if-then. That makes it nice and tidy because the dependent variable is the number of guitars. All right, that's the dependent variable. The number of guitars depends on the color. All right, and the color in this situation is beige. So you should be able to identify the dependent and independent variable. Is it testable? Yeah, it's testable. We've collected enough data that more people have. Here's our. We could have a little mock data plot here, and we can have red at this end, and we can have green at this end, and we can have number of guitars. And remember, this is the x-axis, so if this is the x-axis, then this must be the independent variable, and this is the y-axis, so this must be the dependent variable. So the number of guitars depends on the color. So, yes, it's testable, and if it's falsifiable, I mean, we could prove the alternative if red or green were more abundant. I mean, we could falsify this. An example of a situation that's not falsifiable is the Salem witch trials. There was no way to prove that someone was not a witch. You can't prove it false. If you can't prove it false, it's not of science. You need to be able to prove that something's false. That's the hallmark of a good hypothesis. All right. Now, if guitar players purchase a guitar, it will be beige because they like it. Now, this is a poor hypothesis. This is not a hypothesis because you can't measure like it, and whether somebody likes it or not. That's not testable. No matter how hard I try, someone's going to say that they like it, because it's not something I can measure. And so, really, we only want to have components of our hypothesis that are empirical, measurable. You can plot. You can't really plot like it, and you can't convince someone that it's false, that they like something. You might have components that make it look like science, and that's what these diet pills, and that's what a lot of people do. They have the components to make it look like science, but because it has components that are not empirical, that are not based on facts, that are not based on things you can measure, it's not of science. People only think it's of science.